Okay, this is chapter 6, day 10. We've gone over binomials, and now we're going to compare them to the geometric distribution. This distribution is often called the waiting time distribution, and it's a cousin, essentially, of the binomial. They're very similar, okay? The binomial attempts to find the probability of successes in a given number of trials. What are the chances I go 5 for 10 from the free throw line when I am a 70% free throw shooter? The geometric asks questions like, when am I going to see my first heads when I flip a coin? Probably on the second trial. If you roll a dice, when am I going to see my first 6? Probably on the 6th roll. But it examines those, okay? And the geometric distributions requirements does not have a set number of trials. So it's POI. Remember, the binomial is the probability of success has to be consistent. The O is the outcome. There's got to be 2 of them, success and failure. T is set number of trials, and I is independent. For the geometric, the probability has to be consistently throughout the whole thing. The outcomes are 2 as well, success, failure, and every trial is independent. But it doesn't have a set number of trials because in theory, the geometric distribution goes on forever because you may actually never have a success, okay? All right, you can read all of these calculator keystroke stuff on your own. You have those on the notes. Let's look at the mean and the standard deviation of each one. The mean, as we know, the binomial is number of trials times probability. The standard deviation is the square root of n times p times 1 minus p, also known as q. Now, the mean of a geometric is kind of intuitive. It's 1 divided by the probability. Let's go back to those 2 examples that I gave you. The chances of getting a heads on a flip of a coin is 50%. So if you go 1 divided by 0.5, you'll get 2, which is the intuitive thing you would say is, when am I going to see my first heads? Probably on the second flip. It could be the first, it could be the third, fourth, fifth, forever, but on average, it'll be the second flip. Rolling a dice, the chances of getting a 6 is 1/6. So you realize that the first time you see a 6 is probably on the 6th roll on average. That's 1 divided by 1/6. It's just simply intuitive. There is not a standard deviation for the geometric because there are no fixed number of trials, as mentioned previously. Okay, now we're going to look at some problems that are either binomial or geometric, and I'll show you multiple ways of doing them. Here we go. Okay. Suppose the probability of getting to college is 75%, college acceptance times. Find the probability that you don't get accepted until the 5th college. This is the geometric distribution, not a binomial. Here is one way to do it on your calculator. Second vars or second distribution, second, and then the vars button. Geometric PDF, type in the probability of success, 0.75, comma, then the number of trials you're looking for, 5. You don't type in the number of trials because it doesn't exist. You type in the when you want to see your first success. Another way of doing this, it's actually quicker than this, is to say you failed 4 times in a row and then you finally succeeded. That's actually the faster way to calculate this problem. Because if you got accepted on your 5th try, that means you failed, and then finally succeeded. So that's actually easier to do on this one. Okay, B. What are the chances you got into all 7 you applied to? This is binomial. There's a set number of trials there. You got into all 7. So this is binomial PDF, 7 trials, 75% chance of success, and then 7. Also, in this case, you can just do 75 to the 7th power, because in this case there's only one way to get accepted to all 7. You go 7 for 7. So that's another way to do that. Okay, save. It will take up to 4 applications until I get to college. It'll take up to 4. Okay, what are the chances that you're gonna get it on the 4th try? Okay, so again, on the 4th try, that's gonna be 0.25 to the 3rd times 0.75. Okay, or it's gonna be this on your calculator. Okay, D, you applied to a college and got into at least 3. At least 3 means 3 or more. So we're going to subtract 1 minus 2 or less, if you remember that. Okay, binomial CDF, I capitalized the C for you. Okay, 8 trials, 75% chance of getting in, and then a 2. This will group together the chances of getting to 2, 1, or 0 colleges. If I do the complement 1 minus, I will be left with at least 3, which is 3, 4, 5, 6, 7, and 8. Those 6 probabilities added up will be done with this. Okay? All right. Okay, item E. Applied to 10 colleges and got in fewer than 7. Fewer than 7 is 6 or less. So that's going to be binomial CDF. 10 colleges, 75% chance of success, and then a 6 or less. F, it won't take more than 6 applications until you've been accepted. It won't take more than 6. So I'm going to get in on the 1st, or the 2nd, or the 3rd, or the 4th, or the 5th, or the 6th. Okay, so the chances of me getting, this is a geometric CDF problem. The chances of me getting in on the 1st try is 75%. Or I could get in on the 2nd try, which means I failed first and then succeeded. Or I could get in on the 3rd try, which is I failed twice and succeeded. I would keep going until I got to the 6th trial, okay? Or you could go to geometric CDF and just let it add it up together, okay? If you apply to 12 schools, how many do you think you got accepted into? This is just simply the mean of a binomial, okay? And then H, on average, how many schools do you expect to have to apply until one finally accepts you? Again, that's 1 divided by the probability. About 1.3 schools on average until one takes me. Okay? All right. Okay, set B. Suppose the probability that you will get any girl to say yes to going to the prom is 35%. Prom season, and you think you're the kind of guy that a little over 1/3 of the gals would say yes to. Okay, you ask 4 and 2 of them say yes. That would be tough. Okay, so that would be 4, choose 2, times 0.35 squared, times 0.65 squared. Remember, these 2 add up to 1, and these 2 things add up to the sample size, which is 4. And this is binomial. You can go through it again. Probability is the same, 35%. Let's just assume it's a consistent number. There's 2 outcomes. She says yes or no. Maybe is a no, by the way. Set number of trials. In this case, it looks like it's 4. And every girl's independent in their thinking. That is for sure. Okay? So B, you have to ask 4 girls until you get a date. This is geometric. Okay? And finally, the 4th girl says yes. Probably the easier way is to say the first 3 said no, and then the 4th one said yes. That's probably a little quicker actually than doing it this way, okay? If you ask 5 girls, at least 2 will go out with you. This is binomial. At least 2 will go out with you, at least 2. That means I'm going to go 1 minus 1 or less right here. So this is binomial CDF. I got to add together the probability of 0 people saying yes or 1 saying yes, and then go 1 minus that, and you'll come up with the answer. Okay? And then D, it will take up to 6 proposals until you get a date. Finally, on the 6th one, you get one, okay? So again, that's a PDF one. On the 6th one would be 0.65 to the 5th times 0.35, okay? All 3 of the girls you asked said yes. All 3, in this case, by the way, it is binomial, but if all 3 say yes, there's only one way that can happen. That's 0.35 cubed. You could check, that's the same as that, okay? And then asked 8 girls, and fewer than 3 of them said yes. Fewer than 3 of them said yes, okay? So, fewer than 3 is 2, 1, or 0. So I'm going to do binomial CDF, 8 trials, 35% chance of success, 2, and then there's my answer. All right, on average, how many girls do you expect to have to ask until you get a date? Okay, that would be N, if it's 4, times P, which is 0.35, okay? And 4 times 0.35, okay, there we go. Okay, all right, so that would be 1 divided by 0.35. 1 divided by 0.35, that's 2.857. And then if you ask 10 girls, how many do you expect to say yes? This is binomial. 10 times 0.35, and that's 3.5. Okay? Good luck.